Hello there, you are about to learn how to build awesome and advanced desktop applications that matters with web technologies you already know or heard of, which is HTML, CSS, and JavaScript. This is a 3-hour course on building advanced desktop applications with the Electron Framework. And in these 3 hours that we are going to spend together, we will be building a stunning desktop application from scratch. Now, this 3-hour course here is an excerpt from the full course on Udemy, which is 8 hours long and has downloadable resources that you would need with full lifetime access and also certification for completion. Now, this course is going to be so detailed and going to start from scratch. So, we are going to cover everything you need to know to learn how to build advanced desktop applications. Now, in this course, in the full course, we are going to be building 5 different advanced desktop applications. The first one is a fully fledged text editor. We'll be building a complex music player, a system tree music player, a top headlines newsreader, and a radio streaming app. And aside from all this, we also learn how to package our application for all the different operating systems, which is Mac OS, Linux, and Windows. And we are going to cover a lot of topics ranging from how to start setting up your PC or MacBook for building Electron applications, how to package and distribute your applications, building traditional desktop applications, how to build stunning user interface that looks nice. Now, you can go ahead and jump straight into taking the full course, that's the full 8-hour course on Udemy for just $9.99. And this is the cheapest you can get for this course, just $9.99, just $9.99. You can get this full course lifetime access. The official price for this course is going to increase from 19 to 99, so that will be a 90% discount for this course, which is practically a steal. A link to this course page is included in the description below with the coupon code already applied. So just click on the link in the description and it should bring you to this page. And once on this page, just click on buy now and then you'll be enrolled in the full 8-hour course. So thank you for taking the time to watch this intro, and without wasting your time, let's jump into the first 3 hours of this course. Once again, before we jump into writing Electron code, I think it will be great we talk about what exactly Electron is and how it came about. Yeah, I know we are using slides, but I promise you this is going to be the only time we are going to use slides. So let's jump into it. So what exactly is Electron? Now, Electron Framework or Electron JS is a framework for creating native applications with web technologies like HTML, CSS, and JavaScript. So basically, it allows you to write desktop applications with web technologies that you know of, and these desktop apps that you create are cross-platform. That means that they run on all operating systems. So Electron takes care of all the hard part for you so that you can focus on the core of your application. So if you can build a website, then there are high chances that you can build a desktop application with Electron. So that is a basic explanation of Electron. Now, the technical explanation of Electron is this. So it is a mix of Node.js and Chromium. Now, Node.js is a JavaScript runtime that allows you to write JavaScript code and run it outside the browser. So you can run it on a mobile device, on the desktop, and that's what Node.js is. Now, Chromium is a browser engine that is used by some of the most popular browsers out there. Chrome uses the Chromium engine, and most of the browsers are now using the Chromium engine as well. So Electron is a combination of Node.js and Chromium. So what happens is that when you are writing your desktop applications, unlike websites where when you write a website, you don't really know which browser your users are going to be using. So sometimes you'd have to even write support for all different browsers and all different operating systems. And sometimes some browsers might even break your website, and even sometimes some browsers might ship a feature that is not available on other browsers. So it becomes very difficult to manage all these things. Now with Electron, it comes with its own Chromium engine, browser engine, which runs your Electron application. So whatever feature you have from the Chromium engine, you are sure that is going to be on every user's operating system, on every user's version of your desktop application. Because of this, any web application or Node.js application you have already written can be converted to a desktop app using Electron.js. So once again, Electron.js is a framework that allows you to build native applications using web technologies like HTML, CSS, and JavaScript. And these applications you are building are cross-platform. So that means that they can run on all operating systems, that's Windows, Mac, and Linux. Now let's talk about a brief history of Electron. So the whole Electron thing started in January 2013 by an engineer at GitHub called Chen Zhao. The whole purpose was to search for a tool that was going to allow the GitHub engineers build a cross-platform text editor using the web technologies that they know, which is HTML, CSS, and JavaScript. And the whole aim was to make it easier for them to build a cross-platform text editor. And this is where Atom was born. Electron was initially known as Atom Shell, and it became open source in 2014. So the whole thing started in January 2013, and in the same year, July 2013, Atom Shell was born. A year later, in May 2014, it became open source, and another year later, it was renamed to Electron. Now, in June 2016, the first version of Electron was released, and here we are 3 years after that from version 1, and we are on version 5.0 of Electron. Now, Electron has been used to build a lot of top applications that you know of. For instance, we have Atom, which is an editor, an IDE, which is cross-platform, and it was built with Electron. Visual Studio Code was built by the Microsoft engineers, and they built it with Electron. Skype, the desktop version of Skype, if you know of Skype, it was built with Electron. Even the desktop version of WhatsApp Web was built with Electron. Slack, the most popular productivity tool for teams to communicate in groups, was built with Electron. Also, the desktop version of WordPress was also built with Electron. So Electron has been used to build a lot of top applications, and that is what we are going to learn in this course, how to use Electron to build these applications. So key takeaways: Electron is a JS framework that allows us to build cross-platform desktop applications with HTML, CSS, and JavaScript. It uses Node.js and Chromium to make it very easy and effective to build your desktop applications. So that is it for this section, and that is it for the slides, I promise. We are not going to use slides anymore in this course, so see you in the next section. Before we begin building desktop apps and writing Electron code, there is one requirement that we need to meet. That is, we need to have Node.js installed. And Node.js, what it is it allows us to run JavaScript code outside of the browser. So it is a JavaScript runtime environment that is built on Chrome's V8 engine, and basically it just allows us to run JavaScript code outside of the browser. So with Node.js, we can write JavaScript code for the mobile platforms. So we can create mobile applications with JavaScript. We can create desktop apps with JavaScript, which is what we are going to be doing in this course. We can even create command line tools with JavaScript. And Node.js is going to compile this JavaScript code for us. So it allows us to run all our JavaScript codes outside of the browser. And what we get with Node.js is Node's Package Manager, which is short for NPM. Now, NPM allows us to install any package that is available on Node's ecosystem. So Node has the biggest ecosystem of open source libraries, which means there are a lot of libraries, over 500,000 libraries that have been built and available for you to use in any Node project that you are working on, being it Electron, mobile applications, whatever it is you are working on. You can use Node's package manager, which is npm, to get access to all these open source libraries that are available. And Electron itself is kind of a library that is built that is part of the Node ecosystem. So when we install Node, we get access to npm, and we're going to see how we use this npm stuff in feature sections. But we get access to this npm, and with it we can use it to install any library that is part of the Node's ecosystem. So we are going to set up Node on our PC. To set up Node for Mac OS, we are going to go to the Node official website, which is nodejs.org. And once we visit this site, the page we are going to see is going to present us with two download buttons. One to download a long-term support version, which is LTS, and one to download the current version. Download the long-term support version, with the one with LTS, and once with that, you get support from the Node team for a very long time, and you get to use that Node version for a long time as well. So my current long-term support version is 10.16.0.4. You should have a version that is higher than that. The minimum requirement is to have at least version 8.0 installed before you can work on Electron applications as of now. So go ahead and download any version higher than 8.0 or at least 8.0. So the current version is 13.16.0. So I'm going to click on this button right here to download it, and this should download it. And once it's done, all we have to do is to click on it to open it. So over here I get the pkg version, which is a package for our Node version 10.16.0. Now when I click on it, this should open my package for me, and I have it opening here. And once it opens, we just have to go through a series of steps, answer a series of questions, and we are going to have Node installed. So it's open, and then all we have to do is to click on continue, and this is going to install Node.js and npm for us. So click on continue, and then we continue again to accept the license, and then we agree, and then next we select where we want to install Node.js. I have only one hard drive, so I'm going to select that and click on continue, and then next I'm just click on install. And then once I click on install, it's going to ask me for the password of my MacBook, and I'm going to enter my password and click on install software. And once I do, this is going to start installing Node.js, configure it, and do everything that needs to be done for Node.js to be able to work on my MacBook. And this shouldn't take long to install. It should be done any moment from now. And once it's done, we can now move on and then start writing Electron code. So now it says that installation was completed successfully, and we can close this. Well, I can keep it's going to ask whether I want to trash or keep the installer. I can keep the installer for future use. And to test whether this really worked, we are going to open the terminal, and I have a lot of terminals open. Let me go ahead and close all these terminals and open a new terminal. And once I have the terminal open, we can check whether we have Node really installed by typing node and -v. And once we type node -v, we can see the version of Node that we have, which is version 10.16.0. And if you see this, the Node has been successfully installed. We can also type npm-v to see if we have npm also installed. And npm version is 6.9.0. So we have Node and npm successfully installed on our MacBook. To install Node on Windows, we first have to visit the official Node website, which is nodejs.org.
And once we visit this site, we are going to have two download buttons that will be presented to us, and we can choose which one we want to use to download Node. Now, I recommend you download the long-term support version of Node. This is because when you have Node long-term support version, the Node team is going to keep on supporting your version of Node for over a year. But if you download the current version, usually it's going to be supported for just a few months, and then support is going to be dropped for that version. So if you want to use your Node version for a very long time to build more Node applications, download the long-term support version. Now the current long-term support version is 10.16.0. There is a high chance that you're going to have a higher version of Node long-term support version by the time you are watching this. But the minimum required version to start working on Electron applications is version 8.0. So if you have at least 8.0, you can work on Node applications or Electron applications. So I'm going to go ahead and click on this button, and this should download the Windows version of Node for me. So I'm going to click on it, and it asks me to download. So I'm going to go ahead and download it and start download. And this is going to go ahead and download Node for me. So it should be done in a second. Okay, done. So once it's done, I'm going to go ahead and open it to run it. And this should start the package that we just downloaded. So once you download it, just click on it to open it. And it's going to present you with the Node.js installer. And this installer is going to walk us through the wizard, a series of questions that we need to answer to get to Node installed. So first, I'm going to click on next and accept the terms. And then you click on next again. And then if you want to change the location where Node should be installed, you can change it. But I'm going to leave the default. Click on next. So over here, it just gives us the things that are going to be installed. We have Node and npm. Click on next and then install. And this should go ahead and install Node.js for us. So it should take a while. I'm going to pause it and come back when it's done. If you are presented with a window, with this kind of window, just click on yes to accept it, and it should be done any moment from now. Come on. So it copies some files into the folder that you selected for the Windows, for the Node installation folder. That's the Node installation location, and it's going to copy it in the setup node for your environment so that you can run Node in your terminal. So let me pause it, come back when it's done, and we can continue with this. So my installation is done. It says Node.js has been successfully installed. I'm going to click on finish, and that is it. We have Node installed. Now to test whether it's really installed, I'm going to open my command prompt. So I'm on Windows 8.1. So I'm going to click on this and then search for command prompt. You can also search for command prompt, and they should give you the command prompt. Now we even have two, Node.js command prompt and command prompt. I'm going to open the default Windows command prompt, and to test whether Node.js is really installed, we can type node-v to see if we have any Node version. And we can see the current version of Node we have is 10.16.0. We can also type npm-v to see if we have npm also installed, and we can see the version we have now is 6.9.0. So once you see this, you have Node successfully installed and npm configured, and you are ready to work on Electron apps.
Hi there, welcome to another section in this Electron.js developer course. So in this section, I'm just going to show you the app we are going to be building, our very first Electron.js app, and it's going to be a very awesome app. Let me just show you this app. So this is the app. It's a text editor, and it looks simple, but then there are a lot of moving parts here. And in building this application, is going to help us learn more about Electron.js, all the moving parts. We're also going to learn about PhotonKit, which is a UI library, a front-end library for Electron desktop applications. So let me just show you how this text editor is going to work. So it's just a text editor,
and you can have whatever text you want to have in this text editor. So let me just write something. Build cross platform desktop apps with JS, HTML, and CSS. So whatever text you have in here, you can increase the font size of the text by using this plus button we have here. You can reduce the font size by using this minus button, and you can save the text by clicking on the save button we have here. Now once you click on the save button, it brings up a dialog, and you can name the text whatever you want to name it. And also you can save it by using this file here. So we have menu here for our app, where you can click on file, save, or you can use save as, whichever you want to save the file we have here. So for instance, I can click on save, and let me just call this text app. Yeah, this is a cool name, text app. And then just click on save, and this saves our text for us, and it even gives us the location of our text, as we can see from up here. Now when you notice something, just notice this: as soon as I click on save, we get a green background, and then it goes back. When I click on save, we get a green background, and then it goes back. So just something to show us that our text is being saved. So this app we are going to be working on, and it looks very simple, but then this is a great app. And I think every laptop or PC has a text editor, and knowing how these text editors work is going to be a very great experience for us. So this app we are going to be working on. I'm going to pause here, come back in the next section, and we are going to start working on this app. Wow, great. I can't wait to share my knowledge with you. Hi there. Let's jump straight into building our very first Electron desktop app. And I have a screenshot of the app here. So this is a picture I took of the app we are going to be working on, so that it can serve as a guide for us whilst building the app. So to start, I've created a folder on my desktop called Electron Apps. So this is a folder here, and this is where I'm going to be storing or keeping all the Electron apps we are going to be building. So you can create your apps anywhere you want. I decided to create mine in this Electron apps folder. So I'm going to open this Electron apps folder, and you can see it's an empty folder. I'm going to create a new folder for our text app, and I'm going to call this text app, because why not? And I'm going to go ahead and open this text app in the terminal, because that is what we are going to be using in running our Electron apps and also setting up Electron. Now to open this in the terminal, if you are on Windows, you can click on Shift, you can hold Shift and then right click on this folder, and you should see open command window here, or open Windows shell here, or PowerShell here. Any of those options you see, just click on it, and then that should take you to the terminal. Now since I'm on Mac, I can easily get to the terminal by just writing CD with a space, and then I can drag and drop this folder here, and then once I click enter, this should take me straight to the folder, and we should all be on the same page if whether you're Windows or you're on Mac. Now in this terminal, we are going to start by setting up Electron, and since Electron uses node and npm, we have to use npm to set up Electron. So we start by running npm init, and what this is going to do is going to create a package.json file for us, which npm uses to manage all the dependencies and basically all the stuff that we are going to be adding in our application. So I'm going to run this, and it's going to ask us a series of questions, a couple of questions. Package name, I can just click enter. Version number, enter. Description, enter. Now when you get to the entry point, by default it's going to be index.js. Now I'm going to show you what the entry point is, but then change it to main.js by just typing main.js and then enter, and then you can continue till the end. So in the end, it's going to ask you, is this okay? So this is what is going to put inside our package.json file for us. So I'm just going to click on enter, and what this does is that back into our text app folder, I'm going to open it, and we can see it creates a package.json file for us. Now I'm going to go ahead and open this text app in my IDE, and the IDE I'm going to be using is Visual Studio Code, VS Code. Now you can use any IDE you want, Sublime Text, whatever you want. I prefer VS Code for this. So I'm going to drag and drop my text app into VS Code, and this should open text app in VS Code for me. Now we can see there's only one file here, package.json. I'm going to open it, and we can see what it does for us. It basically puts 11 lines of code in there for us, and we are going to come back and look at what the content of this file here is. But now we've initialized npm, and now we can install Electron. Now back to the Electron, official Electron site. When you scroll down, currently the latest version of Electron is 5.0.4, and just so we are on the same version, let's go ahead and let's install this version 5.0.4. We are going to use this same version for all the future apps we are going to be working on in this course. So back into the terminal, to install Electron 5.0.4, we do so by running npm install, and then we just put in Electron. And to specify the version, we bring at, and then we write 5.0.4, and then this is going to go ahead and then download download Electron 5.0.4, and well, set it up in our text app for us. So I'm going to run this, and this is going to go ahead and then start downloading all the stuff that I need to get this working. So this might take a while. Let me pause it, come back when it's done, and we can continue with it. But it's done. So once you see plus Electron 5.04 added 145 packages, once you see this, it means that Electron has been successfully added to our text app project. So let me go back to my text editor, and I can see back inside my package.json, it has increased from 11 lines of code to 14 lines of code. This is because npm added these 3 lines of code, which shows us all the dependencies we added to our project. And we can see currently we have Electron 5.0.4 added. Also, it creates this node models folder for us, and this node model folder contains a lot of folders in there with some of the codes that we are going to need to get our app working. So I'm going to pause here, come back in the next session, and then we are going to look at this particular line of code here, main, which is set to main.js, and we are going to look at how Electron works. Hi, so in the previous section, we created our text app folder, and we ran npm init, and also we ran npm install Electron 5.0.4 to install Electron for us. Now in this section, we are going to look at why this main.js line here is very important to our Electron application. So to understand this, let's come here, and then let me use a slide I created to explain this. So this is how Electron works. Electron works like the browser you use. Basically, it uses the Chromium engine, which is the same engine Chrome browser uses. So it doesn't use Chrome browser, but it uses a Chromium engine, which is also used by Chrome browser. So this is how Electron works. Electron works like the browser, in a sense that unlike the browser where we have access to the tabs that we create and some of the plugins that we install, with Electron we have access to the whole browser and where it gets saved and everything that has to do with the browser. So it's kind of creating our own browser and then having access to every single part of the browser. Now, just like browsers, we have tabs in the browsers, and that is basically how Electron works. So what Electron does is this: it creates, as soon as you start your Electron application, it creates a new browser, and then the UI you see, which is the code you see, the HTML and CSS code you are going to write in for your Electron app, is going to represent a tab. So your Electron app can have a lot of pages in there or a lot of tabs in there, and each tab is like a unique page on its own. And that is a simple overview of how Electron works. So Electron creates a browser. As soon as you start your Electron app, it creates a browser, and once the browser is created, you use that browser to create tabs in the browser, and each tab it's a whole page on its own. So unlike websites where, let's say on this Electron website where you can have different pages but all navigating in this same tab here, with Electron each page can be on a separate tab on its own. And this is a simple overview of how Electron works. So now what Electron interprets this to be is this. In Electron, the browser that gets created is what we call the main process. So that is like the main Electron guy itself. So back here, this browser that Electron gets created, that is, for instance, if it's Chrome, this whole Chrome browser here is what we call the main process. And the tabs that get created are what we call renderer process. So renderer, like kind of where all the HTML CSS code is going to live. That is the front end if you are coming from a back end, a web background. So this is like our front end, and the main process is kind of like our back end. So that is basically how Electron works. So Electron creates a browser, which is like the main browser, and then the tabs are the visual, like it shows all the HTML and CSS code that we need to see. So back into our code, this main field over here specifies our entry level. That is, it specifies which file represents our browser. And since Electron uses HTML, CSS, and JS, which is the normal web technologies that we know, the browser is a JS file. So we specify which file represents our browser in this main file over here, and where we are saying that the file that's going to represent our browser is what we are going to call that main.js. That's basically what we are saying. Now you can call it whatever you want, but then this is kind of the convention that is used. So I'm going to create this main.js file in my test app folder, and I'm going to do that by clicking on File, New File, and I'm going to save this. So File, Save, and I'm going to save this as main.js, and this should create a main.js file for us. So to create our Electron browser, first, mind you, we've already installed Electron in the previous section. So we can use this Electron by creating a constant to represent our Electron app, and we can set this to a require of our Electron. So what this is doing is that it's requiring the Electron that we installed in the previous section, and we have it stored in this Electron here. Now our browser is in this Electron variable over here, and we can get our browser by using the ES6 object destructuring syntax. And what that basically means is this: we can get our browser, which in Electron is called the app, and this is going to extract app from Electron for us, and this app is our browser. Now all that we have to do is to initialize that when our app is ready, we want to do something, and that's basically, we do that by writing app.on, and on is a function that gets called that gets called on Electron to listen to events, so things that happen with our app. For instance, when the app is ready, when the app closes, when the app goes in the background, and a lot of other events that we can have. So we want to do something when the app is ready. So we say that when the app is ready, we pass in an anonymous function here, which is going to run when the app is ready. So for now, when the app is ready, let's just run a log. So I'm just going to run console.log, and I'm just going to log app is ready. So very simple code in here. So let me just recap what we are doing over here. We are requiring Electron from this node package that we just installed, and this Electron can be found in this node modules here. So when I extract this and I scroll down, we can see Electron over here. So we are requiring electrons, and since we are using npm and node knows where to find this Electron model. And then we are extracting this app from our Electron, and this app it comes with Electron by default, which is the browser, and we use that, and all we have to do is to listen to the browser and see when it's ready and when it goes off, and we can do whatever we want to do when the browser is ready or when it's closing, or when it goes in the background. So over here we are saying that when our browser is ready, or when our Electron app is ready, all we want to do is log app is ready. So let's save this, and to run our Electron app, we have to come to our package.json and then create a new node script, and this script makes it easier for us to run our Electron app. So for now, you can see there is a script here called text, which just displays this text here, which is error, no text specified. So go ahead and delete this line here, this test script here, and then let's put in our new script, and we're going to see how to use this script in a moment. So I'm going to call this script start, and when this start script is called, we just want to run Electron dot. And what this does is this: as soon as we run npm and then we call start, it's going to come into this folder, and then it's going to run Electron, which is installed in this folder, and then tell Electron to run this folder by using the dot. So dot means this particular folder here, which is still going to come back to this package.json, look at the main, which is specified as main.js, and then go to the main.js file here and then start our Electron app. So that's the process. So I'm going to save this and then open my terminal and make sure I have my text app open in the terminal, which I have here. Now I can clear my terminal by running clear to clear up all these things here. If you're in Windows, you can do it by running CLS instead of clear. Now, to run this script we just created, which is start here, I can come back to my terminal, and to run it, all I have to do is run npm and then the script we created, which is start. And then what that does is it runs our Electron app, which tells Electron to run this folder, and then it comes to this folder, and the first file it looks for is our package.json, and then it goes into package.json, looks for the main, which is our browser or our entry point, and we specify that to be a main.js. So it goes into the main.js, and then it runs the code we have here, which is basically getting Electron and then starting our Electron app. So if everything went well, we should see app is ready logged in our terminal. So if I come back to my terminal, we can see app is ready logged here. That means that our app is ready. So we're going to pause here, come back in the next section, and then we're going to look at how to add the tab or the renderer process to our Electron app. Hi, so in the previous section, we got our Electron app running. Well, not a complete Electron app, but then we got the browser part of Electron running, which is the main process. We got it running, and we specify that when our browser is ready, it should log a console text for us. And we got our text logged in a terminal, which shows that our app is ready. Now in this section, we are going to look at how to add the renderer process, or the tab, the tab side of things, or the UI of our Electron application. And so let's just jump right into that. Now, our renderer process or our UI is going to be a simple HTML page. So I'm going to start by creating an HTML file first, which is going to be our renderer process. So I'm going to do that by creating a new file in my text editor folder, and I'm going to call this file index.html. And this is just a simple HTML file that I've created. Now back into our main.js, we have to tell our browser that this index.html file we just created is one of your tabs, or is a renderer process that you have to use. And to do that, we need to destructure another object. We need to destructure another object from our Electron, which is called the browser window. So we need to destructure a browser window, and this browser window is basically a tab, and you can even see the name says it, a browser window. So now that we have a browser window, all we have to do is to instantiate a new version of this browser window. So I'm going to go ahead and then delete my log, and then I just create a new browser window. So I'm going to create a new variable for our window, and I'm going to set that to a new browser window. Now this browser window takes options, and that's basically how big our window should be, how long it should be, like the width, the height, and some basic configurations that we can pass to this. So I'm just going to pass in an empty object. We won't pass in any any options for now. Now that we have a browser window, all we have to do is to tell this window which HTML file it should use. And we do that by telling our window, calling a function on it called load file. And this load file function here takes a path to a file, an HTML file. And over here we have the HTML file in the same folder as our main.js. So we can just tell it to run the index.html file that it finds in the same folder. Now, if our index.html file was located in another folder somewhere, they will have to specify that part here. But since the index is in the same folder as the main.js, basically on the same level, we can just specify the index.html file here. And then I'm going to go ahead and save this. And that is basically it. Once we do this, we've created a new browser window and we've told it which HTML file to use. Now, before we run this, let's go ahead and put some content in our HTML file and let's see if that gets displayed. So I'm just going to put an h1 tag in here. So h1, and in this h1 I'm going to write a text, my very first Electron app. So all we have here is a simple h1 tag that reads my very first Electron app. So I'm going to save this file as well and then go back, and let me just mention this. Anytime you modify your main.js file or your main entry point, you would have to come to the terminal and then you'd have to stop the current running process, because you can see it's still running, it hasn't stopped. You would have to stop it and then run it again. And to stop it, you use Control C on Windows, and if you're on Mac, you use Command C. Sorry, still Control C on Mac. So use Control C on Windows or on Mac, just use Control C, and this is going to stop it as you've just seen. And then all we have to do is run npm start again. And when I run this, hopefully we should get a window, and boom, we have it. So we have a browser window showing, a tab showing with the h1 we just placed in there, my very first Electron app, everything showing in here. So that is basically how to add a browser window to your Electron app. So let me just do a quick recap of what we just did. So we created an index.html file which is going to represent our tab or our front end, and then all we did was to import a browser window from the Electron that we required up here, and then we created a new instance of our browser window, and then we told our browser window to load a file called index.html which we created. So all this code here runs when our app is ready. And that is it. Inside our index.html, we just have one h1 tag here with a heading, and this heading is what gets displayed when we run our Electron app. So that is it for this section. We are going to come back in this next section and then continue with our app. Thank you. Hi there. So in the previous section, we got our renderer process showing. So basically what we did was to display our very first text in our Electron desktop application, and we almost have a complete desktop app. So although this is nothing fancy, but this is a very great step in our learning process, because we've seen how an Electron app really works, how the renderer process and the main process comes together to display something in our Electron app. And the next step that we need to do is to build the interface of our desktop app. And I think I have an image of that here. So this is it. So this is an image that I took of the app that we are going to be building. And the app, which is a notepad or a text editor, is going to have a plus and minus button to increase and decrease the font size of our editor, and also a save button which is going to save whatever we write here into or it's going to save it on our PC or desktop. And also we are also going to have a menu that is going to be added to it. So but then basically the interface is going to have a plus minus button, a save, and then this big text field over here where we can write our text. And we are going to be building this using a UI, a CSS framework for Electron called Photon. So let me show you that framework. So I'm going to go to my browser and then open a new tab, and then visit the official Photon page, which is photonkit.com. Now, so this is the official documentation page for Photon, and this is a CSS framework for building Electron applications. And there are a lot of components in there that we can use to build our Electron app. So I can easily let's go to the components and see all the components that we have under Photon. So well, we can see we can have headers with icons, bars, we can have footers. There are a whole lot of stuff that we can add to our Electron application. And when you go to the getting started, it gives you the link to download Photon, and just use the CSS and HTML files that you need in there. So once you download Photon, all you need, so you can see this is the structure of the Photon that you are going to be downloading. There is a CSS folder in there, there's a font folder in there, and there's a template app. All you need is this CSS and this font folder, which I have already downloaded and attached to this lesson, so you don't really have to re-download everything. So I have it downloaded on my desktop, and it's here, Photon, and the CSS and font folders are in there. So you should find it attached to this lesson. If for some reason you can't find it, you can go to photonkit.com/getting started, or go to photonkit.com, click on getting started, and you should see the download link where you can download you can download Photon again. So I'm going to go ahead and then add the CSS and font folder that I have here inside my Photon folder. I'm going to add it to my text app project. So I'm going to copy these two folders, copy them, and I have my Electron app, the text app, inside my Electron apps folder, text app, and I'm going to paste it in here. So I paste those two folders in my text app folder, and let me just show you what we have in those two folders. When I open the first folder, there are just two files in here, Photon CSS and photon.main.css. And also when I open the font folder, there are just some font files in here, so nothing fancy in here. Now, so we've added Photon to our Electron app. So we are going to pause here, come back in the next section, and then look at how to use this Photon that we just added. Hi, so in the previous section, we added Photon to our text app project, and we can see that I have CSS and font folder from Photon added to my text app project. So if I open my Visual Studio Code, I should have that added, and we can see that here. So let's go ahead and link this CSS and font folder, but basically we are going to be linking only the CSS folder in our renderer process. That's our HTML file here. So I'm going to clear the text we have in there, and since it's an HTML file, we need the default HTML structure. So I'm going to start with my doc type, or if you are using VS Code, you can just type HTML and then select HTML5, and you should have the whole HTML structure displayed for you. So you should have the whole HTML structure in there for you if you are using VS Code, and this makes the development process very, very, very easy and fast. So all what it does is it gives us the doc type, the opening and closing HTML tags, the head and body tag, and inside the head there are a few meta tags that are specified there. Nothing fancy, just basic HTML structure here. Now let's change the title, and this title we specify here is the title we are going to see up here in our app. So whatever we have up here is going to be the title. So for now, let me just call it text app. And then now in over here as well, below our title, let's go ahead and let's link the CSS file we have from Photon, which is this CSS file we have here, Photon CSS. So I'm going to go ahead and then link that by using the link tag, and all I have to do is specify the href of the link tag. If you are using VS Code as well, once you type link and then enter, it gives you the whole line of code. But then let me just type it from scratch. So we can have link with our href, and the href is the location of our CSS file, which is inside our CSS folder, and it's called photon.css. So let me just minimize this. So we have CSS and then photon.css, and let me also specify my rel, which is style sheet. So now we've successfully linked our Photon CSS to our Electron application. Basically, we've linked it in our HTML file. So let's continue by building the UI of our application. Now, since this is not an an HTML CSS course, I wouldn't go much into the HTML syntax and also the CSS syntax. So I assume you know how to use HTML CSS, you understand classes and those basic HTML stuff. So I wouldn't be explaining much into the HTML except when I have to. So back to the Photon documentation, under getting started, when you scroll down a bit, is under application layout. This text here says that every Photon application has the same basic structure that consists of a main .window class element and with the corresponding window content. So basically, every Electron app has this div which wraps around all the code. Sorry, every Photon app has this div which wraps around all the HTML code, and this div here for the main body. So let's scroll down and let's see if there's anything fancy here we can use. Okay, so down here, the basic template. Let's just copy this basic template. Let's just copy this basic template we have here, which is the basic structure of a Photon project. So let's copy it, paste it into our app, and let's see if anything fancy pops up. So let's copy this back into our IDE. I'm going to replace everything here with the basic structure that I have. And also, once you replace, don't forget to fix the link that we have here. So the link is not just photon.css, but it's supposed to be css/photon.css. So I'm just going to fix that, css/photon.css. And also, this Electron JavaScript here, well, we don't need it. Just go ahead and delete this second line here under Electron JavaScript. And now let's go ahead and save this. And remember, I mentioned that anytime you modify the main.js file, you'd have to restart this whole process here. But then if you modify the index.html file, all you have to do is just refresh this your Electron project here. And to refresh it, you can just click on view, which is a part of the menu, and then click on reload. And we are going to look at talk about some of these things over here. But you can click on reload or use Control R or Command R to reload it. So I'm going to click on view, reload, and this refreshes our app, and we have welcome to Photon displaying in our application. So that means that our Photon CSS has been successfully added to our project. So let me go ahead and let me just brief you through the HTML code we just added. So over here we have our head, which has basically two lines of code: the title and the link to our Photon CSS. Down here we have our div of class window, which wraps your entire app, and also we have a header, which is a custom header we are creating. And this header you are seeing here is, let me just show you, is this header we have here. That's why we have double headers. So this header we have here is the header you are seeing here, and then the class window content contains the code for our body. So everything that has to be in here, the main code, goes inside our class window content. So let me go ahead and let me remove this title inside our header, because we don't need any title in our header. Let's maintain the header, we are going to be using it, but let's remove the title from our header. And I can delete this title, save it, come back to my Electron app, refresh it by using Control R on Windows or Command R on Mac, and then we can see the title is gone. Now our Electron app is going to have two buttons in our header, two buttons here and a save button here. So I have the image here for reference, and I've attached this image to the first video in this section, so you should be able to refer to it as well. So we need two buttons, and we need two buttons on the left and one button on the right. So let's go to our Photon documentation and see if there are any piece of code in there to help us add two buttons to the left. So back to our our Photon documentation page. Let's scroll up and then click on components, and this should bring us to all the components that we have access to in Photon. So we can see there are bars over here, bars with actions, and well, we can see some buttons on the left here and one button on the right, which is similar to what we want. So let's look at the code for this. So down here we can see all the buttons are inside this div toolbar action. We can see everything is inside this div toolbar action. Let's just go ahead and copy everything in this div toolbar action. So I'm going to select everything here all the way to the closing tag of the div. So right before the closing head tag, I'm going to select everything. So that's the opening of the div and then the closing of the div. So I'm going to copy it back into my IDE. I'm going to paste it inside my header, and let me zoom out a bit so that we can see the code. So we have this inside our header. Save it, and then back into my Electron project, refresh it, and we have the text that we wanted added up here. So we have everything up here, just as we saw from the documentation here. So let's go ahead and let's clean it up. Now we don't need these filters, we don't need 3 of these buttons. So let's go ahead and let's take out 3 of these buttons and this filters guy here. So back here, let's take off the last 3. So this is button. So I'm going to take off this button 1, this button 2, and this button 3. And also I'm going to take off the filters. So I'm going to delete this whole button as well. And then let's save this and let's see what we have now. So I'm going to save this back into my app, refresh, and now we have 2 buttons with the 1 button on the right. Now this button on the right needs to have a save text in there. And back into our documentation, which I have opened here, we can see there's a button with a text in there. So let's look at what that button look like. So we can see it's just a normal BTN default like all the other buttons, but then just that it has this icon text class added to it, and then below the icon we have the text. So I'm just going to add this icon text class to my span, and then below it I'll put in my text. So I'm going to copy my icon text back here, add it to this icon megaphone, and then below the span I'm going to put in my text, which is going to be save. Just save. So I'm going to save this back into my project, refresh it, and we have a save text here. Now it looks like there's some random character here, and I'm sure this is because of a class that have been added to this button here. So back in here, there is this class btn drop down. Let's take it off because our button is no longer going to be a drop down. So save it back into our project, refresh it, and this button looks just as expected, but then we just need to change the icon. And also these buttons as well, we need to change the icons to a plus and a minus. So back here, let's change these icons to plus and minus. So back here, the first icon is icon home. I can guess icon plus for the plus button and icon minus for the minus button. So save this, refresh this, and we have plus and minus. Also, this one is icon megaphone. I can change it to icon download, and I'm going to show you how I get this icon, these names here. So save it, refresh this, and we have kind of a save button with it, like kind of a save icon. So these icons over here are defined in the documentation page. Once you click on the component, you scroll down to the end, you can see all the icons defined up here, all the icons. And if you want to see which particular icon any of these guys are, all you have to do is just right click on it. So for instance, this is our plus icon. Just right click on it. If you're on Chrome, just click on inspect, and once you click on inspect, let me pull down my inspect window here. pull it down a bit. Once you click on inspect, you can see the icon name here, which is icon plus. So that is where I get the names from. Also, the download is somewhere in here, somewhere here. So I can click on this, and to click, I can use this select element arrow here to click on this icon here, and this icon install. But the download icon here is somewhere in here. Well, there are a lot of icons in here, so you can go through and then you can play around with some of the icons that are in here. But then we have our buttons added, and that is what is really necessary for this section. Like I said, I won't go more into CSS and HTML stuff, just so that we keep into the scope of Electron. So now we have 2 buttons added here. Let's pause here, come back in the next section, because this video is getting longer than expected. So let's pause here, come back in the next section, and then look at how to add a text field to this body over here. Hi there. So in the previous section, we got 2 buttons added. Sorry, 3 buttons, 2 on the left, 1 on the right, which is kind of similar to the screenshot that I took for our application. So this is a screenshot, and we can see the plus and minus buttons there with our save button here. So we are on the right track. In this section, we are going to replace this body text here with one big text editor, which is going to fill this whole place and, well, kind of complete our UI for us, or our front end for us. So let's get to it. So I'm going to go back to my VS Code and scroll down to under window content. This div here contains the code for our body. So I'm going to delete everything in this div, which is this whole code here. Delete it. Make sure you don't delete the closing div of your window content, because these mistakes are very easy to make. Now in here, I'm going to put in a text area. So I'm going to put in a text area, and this text area is just going to be as big as the body and as long as the body. The width and height is going to be the same as the body. So I'm going to give it a width. Let me give it a style attribute, and then set the width to 100%, and then also set the height. Sorry, set the height to 100% as well. So save this, back to my my Photon app, refresh this, and we should have one big text editor in here, as you can see. Well, this is kind of going the right direction for us. We have our buttons and our text area. So let's go ahead and let's remove this blue layout on the edge, and also there's this 2 lines down here. Let's go ahead and then let's remove that as well, and we can do that with CSS. So we can remove this 2 lines here by setting another CSS attribute, which is raise size, setting raise size to none. Save it, refresh this, and then those 2 arrows down there vanishes. Now it's left with the border we have here. So let's go ahead and then let's remove this border that we have over here. So back into our CSS code, sorry, our HTML code, we are going to add, let's add a border. Let's set border to none, and then let's see if this works. So back into our Electron app, refresh this, and it's still there. Okay, let's add one more CSS attribute, that is outline. Let's set outline to none as well to clear the whole outline. So back into our app, refresh this, and we can see the outline is gone, and I can type stuff in here, but it looks very small by default. So let's come back here, let's add another CSS attribute. So let me set the font size, let's use 20 pixels. Save this, come back, refresh this, and then, well, now it looks a bit bigger. So we have our UI complete, basically. Like, we have our front end complete. As we can see, everything in here is working just as expected. These buttons don't work because we've not worked on them yet, but then the UI of our app is complete. So before we end this section, let me go ahead and let's move this attribute we have in here into a class so that we can just reference the class in our text area to make things easier. So I'm going to come up here, create a style attribute, and in there create a class for our text area. Well, let me just reference my text area and copy all the code I have inside my style, cut everything for my style, and then put them in my text area here. Let me format it well. And this should affect my text area. So let me go ahead and remove this style attribute from here. Save this back into my app, and hopefully nothing is going to change. So I'm going to refresh it, and we can see the layout is gone and the 3 lines are still gone, and the font size is still big. Well, yeah, so we have our UI ready. We are going to pause here, come back in the next section, and then we are going to look at how to make these 2 plus and minus buttons here work. Hi, so in the previous section we got our UI complete, so the user interface of our app is done, and let's go ahead and let's get these 2 buttons here working. Let's plus and minus buttons here working. Currently when I type anything here, this is there's text. When I type anything here and I use the plus or minus buttons, they don't really affect this text here. So let's go ahead and make sure that when this plus button is clicked, it increases the font size, and when this minus is clicked, it reduces the font size. So back into our code, I can go and look for those 2 buttons and then just add on click to those buttons. So I can add the on click attribute, on click, and these on click attributes are available in Electron. If you are using Electron, you can access these on click attributes since it uses JavaScript, and this works on all HTML JavaScript projects. So we specify on click, and we can say that we can specify a function here that should be called when this plus button is on click is clicked. So we've not created a function yet, but then let's call a function called increaseFont. We've not created a function yet. Then also let's set on click for our minus button. So on click, when our minus button is clicked, we want to call decrease font. So 2 very simple functions. So let's go ahead and let's define these functions. So down here, before my closing body tag, I'm going to use a script tag to write all my JavaScript files, my JavaScript code. And in here, let's go ahead and let's define our increase font function and our decrease font function. So function decrease font. So we have those 2 functions defined here, increase font and decrease font. Now when this font increase font over here is called, we want to increase the font of our text area. So first we have to find this text area, and we can do that using normal JavaScript DOM query or document object query. So I'm going to create a variable to represent our text area, and to find our text area, I can just do document dot query selector and pass in the object that we want to select, which is a text area. So just pass in this, and this is going to go through our object and look for a text area for us. So now we have access to our text area. Now we have to increase the font size of this text area, but then we have to find a way to track the font size. So let me create another variable for our default font size. So our default font size, and by default somewhere up here we set it to 20 pixels by default. So I'm going to set it to 20. So in here, what we want to do is take our text area and then change the font size of our text area. And we can do that by calling text area dot style dot font size, and then we can set that to a new string of whatever font size we want. So we want to set that to the default font size plus 1 because we are increasing it. So we have to want to set that to the default font size +1, and we are, since it's a size, we need to add the unit, which is the px, to it. So we can use string template, which is the backticks. So we can use the backticks, and over here we can say that here we want to put in the default font size +1. So we can do that by doing ++ the font size, and then we add the px to it. So this is JavaScript string template syntax, which is the backticks, and we can embed variables in strings using this dollar and then this bracket here. So what's happening is that anytime this increase font function is called, we take the default font size, whatever font size we have, add 1 to it, and then set as our new font size. We are going to do the opposite for our decrease font size. So when decrease font size is called, we want to get our text area, and then we want to call the star on it. We want to set the font size of our text area, and still we are going to use the string template. And over here, instead of plus, we are going to minus because we want to decrease. So minus the default font size, and then add our px at the end. So this is it for our increase and decrease buttons. Let's save this, and then let's refresh our Electron app, and hopefully this should work. So I'm going to refresh this, have some text in here. So this is a test, and then hopefully when I click on this plus button, it's going to increase the font size. So I'm going to click on it, and we can see it keeps on increasing the font size whenever I click on it. And when I use the minus, this should reduce the font size. So when I click, it reduces the font size. So we have these two buttons here working just as expected. So we're going to pause here, come back in the next section, and then get our save button here kind of working. So see you in the next section. Hi. So in the previous section, we got our plus and minus buttons working. So increasing and decreasing font works now. In this section, we are going to get our save button kind of working. Not completely working, but then at least we are going to get the structure of it working. So let's go back to our code, and then let's add an on-click to our save button. So this is our save button here. So when this button is saved, so it's clicked, on click, come over here, on click. So on click, we just, let's call a function called save text, which we haven't created yet. So on click, we're going to call a function called save text, which should take care of getting the text from our text area and then saving it for us. So let's go and let's create this save text function. So I'm going to create a function save text, and this function first has to get the content of our text area and then go ahead and then save it for us. But for now, let's get the content and then let's log it. So let me just create a variable for our text, and this is going to be the value of our text area, and we have our text area defined up here already, so we can go ahead and just use that text area dot, and once we can call value dot value, and this is going to get the value of our text area or whatever text we have in our text area box for us, and we can have it in our text. So for now, let's go ahead and then let's console dot log our text, and then let's save this. And once we save this, we can let's go ahead and let's refresh our application, because we just edited the render process, the front end of things. We just edited the front end. So let's go ahead and let's refresh our application, click on the save button, and then let's see if it's going to log the text that we have for us. So we're going to refresh this, have some text in there. So this is a text. Let me increase the font, and then once I click on save, this should log the text. This is a text for us. So I'm going to save this. So I've clicked on it, and then let me check my terminal to see if there are any logs in there. Oops, there are no logs in my terminal. So this is a quick got you. So back in here, what happens is that when you want to check the logs, or you want to debug your renderer process, which is the front end of things, it's kind of different from when you want to do it for the main process. Since the main process is the app itself, the browser itself, which is run from the terminal, everything that has to do with the main process goes to the terminal. But the renderer process is like a whole tab on its own, which is just launched by our main process. So to debug this renderer process, by default, when you click on view on the menu and you click on toggle developer tools, it's just like the Chrome developer tools if you've used it before. As you can see from here, it's just like the Chrome developer tools, where the elements and the console and everything that has to do with the Chrome browser is. So this even is a proof that Electron is just like a browser. So it uses the Chromium engine and then it works with tabs. So this is a tab that we are just editing. So you just click on view, toggle developer tools, and it hides it again. Click on view, toggle developer tools, and it shows it again. And then once you have it toggled, you can click on console and you should see the log that we have in here. This is the text. So whenever you are debugging your renderer process, you use this developer console here, the developer tools here. So everything that has to do with the renderer process, the network, everything that has to do with the renderer process can be debugged here. And when you are dealing with the main process, you debug it with the terminal. So now back into our application, I'm going to refresh this whole UI, write some text in here. This is another test. Click on save, and we have this another test login here. So from now onwards, I won't be calling this interface here the UI. I'll just be calling it the renderer process, since that is what it is. So I can click on save again, and then anytime I click on save, we can see it increases the number of logs that we have for this text here. So now we're able to get the content and then getting it logged. That is one step of the process. Let's pause here, come back in the next section, and then look at how we can send this text here and then save it in a text file. Hi, in the previous section, we were able to get text from our text area or text view here, and we were able to display that text in our console. In this section, we are going to look at how to take this text and then save it in a file on any part of our PC. Not necessarily save it, but we are going to look at the concept behind that. So to begin, I would like to take you back to a slide that we saw in the beginning. So okay, there is a slide here. So in the beginning, we talk about the main process and the renderer process, and we said the main process is kind of the browser. It's kind of the main browser, and the renderer is the tabs that we have in our browsers. So the main process launches the renderer process. And let me just mention this: we can only have one main process in every Electron app, but we can have multiple renderer processes. Alright, now back to what I wanted to talk about. In Electron, when you are writing code, or when you want to do something in your Electron application, and that thing has to do with accessing a feature of the operating system itself, then the code for doing that has to be in the main process. So this is what I mean by that. When you want to write code that targets the camera of your operating system, or that targets the RAM, or targets the activity log, or whatever that has to do with the operating system itself, or that has to write files to your PC, everything that has to do with manipulating the operating system has to go in the main process. Now, this is mainly because when you are writing code and you put the operating system stuff, things that has to do with the operating system in the renderer process, it opens your code to a lot of errors. Now, this renderer process is just a browser, and that means that whenever this process goes off, you don't have access to any of the code that you have in the renderer process. For instance, I have two tabs here. As soon as I close this tab, I don't have control of any URL or anything on this tab ever again, unless I reopen the tab. And that means that I cannot use any of my tabs to access this tab. Like, I cannot do anything to this tab as soon as so far as it's closed. So if, for instance, in this tab over here, I have, let's say I have this ad blocker Chrome extension in this tab here. As soon as I close this tab, I do not have access to this ad blocker again. And that is basically what's going to happen. If you put your code for, let's say, accessing the camera in this render process, and then this render process goes off, you don't have access to it again. And that means you have to write the code for accessing the camera in any other render process that you might have. So if I have 6 tabs and I want to use this ad blocker here, I would have to code the ad blocker in all 6 tabs, and that is too stressful. Now I can easily solve this by just putting the ad blocker in the browser itself, just like it's been done here, and I can use it in any of the tabs that I want. And that is basically what we have to do. When we are working with Electron applications, we have to put code that is specific to the operating system in the main process, and then code that has to do with our render process, that is our web pages, our HTML stuff, everything in our render process. So that is basically how we architecture Electron applications. Now, to the next concept that we have to understand here. Now, in Electron, there are 2 main processes, and this process, render process here, is different from the main process. And as we saw from how we logged our text file here, whatever text I have here, if I click on save, it logs the text inside the console here. It doesn't log it in my terminal. But then when we try to log something in our main process, that thing rather gets logged in the terminal, which means that these 2 processes are different from each other. And we have to find a way to send a message from our render process here all the way to our main process here. So we have to find a way to send messages between these 2 things. And that is what brings us to the next concept that we have to talk about, which is IPC. So IPC stands for Inter-Process Communication. Once again, IPC stands for Inter-Process Communication. And Electron uses IPC to communicate between the render process and the main process. So whenever the render process wants to send a message or data or whatever information it wants to send, whenever it wants to send it to the main process, it uses the IPC that is provided by Electron, and then it uses the IPC to send the data to the main process. Now, the main process also uses the IPC to get the data that has been sent from our render process. And once it gets the data, it can do whatever it wants to do with it. The same way, the main process can send data using the IPC that is provided for the main. So the main process uses this IPC to send data from the main process to the render process. And the render process also uses this IPC to get the data that has been sent from the main process and then do whatever it wants to do with the data. So this is how it works. IPC renderer sends, let's say, WhatsApp. And then once the main process gets WhatsApp, it can reply with whatever data it wants to reply with. So let's say it replies with cool. Also, the IPC main can send a data, let's say hello. And once it sends this hello, the IPC renderer will be listening for whenever a hello is sent. And as soon as it gets hello sent, it can reply with hi. So that is basically how the communication is going to work. So IPC renderer is going to be waiting for certain messages to come. And IPC main can also wait for certain messages to come. And once IPC main gets the message, we can do whatever we want to get after we get the message. And the same for IPC renderer. Once it gets the message that it's waiting for, we can do whatever we want to do with that message. So this is basically how it's going to look like. Our IPC renderer will send messages. Our render process will send messages to our main process using the IPC renderer, which is the IPC for our renderer. And our main process is going to communicate with our render process using the IPC for the main processes we call the IPC main. So that is basically the main concept behind communication between the processes, where one process sends an event or sends something, a message to another process, and that process can either reply or do whatever it wants to do with the data it gets. So we are going to pause here, come in the next section, and look at how we can apply this IPC main and IPC renderer things that stuff we've been talking about. We are going to look at how we can apply it in our application and send the data from our render process here to our main process. Hi there. In the previous section, we spoke about inter-process communication, IPC for short, and we are going to look at how to apply that in our application in this section. So we said we are going to use the IPC to send the data from our renderer process here to our main process here. And also we mentioned that to send data from our renderer process to our main process, we have to use the IPC renderer, or the IPC for the renderer, which is called the IPC renderer. And to get access to that back into our code, we have to get access to our IPC renderer from this require electron over here, because IPC is part of Electron, and to get access to it we have to first require Electron and destructure it just like the way we are doing for our app and our browser window. So first let's go ahead and let's require Electron. So require Electron, and now we can destructure our IPC from Electron by getting the IPC, and it's called IPC renderer with a capital R, IPC renderer. Now as soon as we do this, we have access to our IPC, and then now we can use this IPC to send data to our main process, and we do that with just one line of code. So this is the data we want to send. Now over here we just call our IPC renderer, and we call the send button on the IPC renderer. Now it takes two things. First, it takes a key for our data, so it takes some kind of message for our data. So we can send a lot of data to our main process, and our main process can do different things based on the data that it gets. So to tell it the kind of data that we are sending, we have to give the data some kind of key, right? So that we can use that key to know the data that is coming into our main process. So I know it might be a bit confusing, but then let me do it so that you get it. So where we can see that in our we should send a message to our main process. We are going to call this message save, and as part of the message we want to send this data, which is the text. So what this is going to do is this: we are going to set up our main process here to look out for a message called save, and once it gets that message save, or a notification called save, once it gets that save, you should go ahead and then get this content here, and then you should save it. Now we can also tell it, so the reason why we do this is this: we can send another message and tell it that, okay, this time I want you to delete, and then I can pass it the text, and then maybe with this we can say that whenever this guy, our main process here, gets the delete notification or the delete message, it should go ahead and then delete this text. So that is why we actually need to give it these keys over here. So once we do this, automatically Electron takes care of sending the data from our renderer process to our main process, because there is only one main process. So we don't need to specify which main process we want to send it to, because there's only one process. So Electron sends it straight to our main process. Now in our main process, what we can do is to listen for this message, to wait for this message whenever this message comes. And from our slide here, we said that we do that using the IPC main. So in our main process, back into our main process, just like the way we got the IPC renderer from Electron, we have to get the IPC main from Electron as well. And we also get it with the object distraction as well, or this word always confuses me, destructuring. All right, great. So we get our IPC main from our Electron, and we can now set up this IPC main to listen for events, to listen for these things that are coming. So to do that, and we can do it outside our app when our app is ready. So to do that, all we have to do is to set up IPC main dot on, and then we pass it the message that it has to listen to, and the message we want it to listen to is this save message here. So we tell our IPC that on save, or whenever you get the save message, what do you want to do? You want to run something, you want to do something. So we pass in an anonymous function or an arrow function, which is going to run whenever save is called. Now the function gets passed with two parameters. The first one is the event, and the event has to do with which renderer process called it and a lot of other data that we don't need at this point. The second data that comes to it is our text itself. So this is the text that we are passing to it. So when this text comes here, what do we want to do? So this is the point where we can go ahead and then save the text to a file. This is the point where we save the text to a file. But before we do that, for now, let's go ahead and let's log this to the console. Let's log the text we get to the console, just so we know we are getting the text. So we log it to the console.log, and then we pass it our text. So this is what's happening. Just a quick recap. Over here, we are telling our IPC renderer to send this text, to send a save notification, and the data is this text that we have here from our text area. In our main process, we are telling that whenever we get a save notification, we want to log the text that gets passed to it. So I'm going to save this, and remember, anytime you modify your main process, you always have to restart your running process over here, your Electron. You have to stop it and then run it again. Anytime you edit your main process, that's your main.js here, you have to stop it, stop this, and then start it again. Else, when you come here and then just refreshes it, you are going to get the changes you did in your I'm going to get the changes you did in your render process, but then the main process changes won't have effect on our project. So we have to come here, stop our server using Ctrl+C, and then start it again. And once we do this, it's going to get the updated version of our main process. Now there's going to be an error in here. So let me click on View, Toggle Developer Tools, and we can see the error here. It says that unquote reference require. Now this is mainly because the require we are using inside our render process here by default is not available. It's not available by default in our render process, not even in browsers by default. And we have to tell Electron that we want to use this require in our Electron process. Now, because we have to specify this explicitly, because in Electron or in normal browsers, this is not available. This require over here is not available in browsers, and we want to use it, so we have to specify it. So let's pause here, come back in the next section, and then look at how to fix this require issue here. Hi, so in the previous section, we added this IPC renderer and we sent the text data, the text value of our text area to our main process. But then we got this require error here, and we're going to look at how to fix it in this section. So you should keep this code here in handy. So what we're going to do is, we have to tell our Electron application, the whole main process, that we want to use our node, our require, and everything that has to do with node itself, because this require syntax here is available in node when you are using node. So you have to tell that I want to use this require and everything that has to do with node in our renderer process. And to do that, we have to come back to something we've ignored from the beginning, which is our browser here and the options that it takes. So we said this browser takes a lot of options, and we left this empty at the beginning, and I said we're going to come back to this, and this is the point where we start looking at this. So in this options that this browser take, there are a lot of options that it take. It takes a height, it can take a width, it can take a minimum height, a minimum width, and a whole lot of processes. So a whole lot of options. The option we need right now is the web preferences options. And this web preferences option, with this we can tell our main process that we want to use the require and everything that has to do with node in our render process. And web preference itself takes an object, and in this object there is one attribute that we want to set to true in there, which is node integration, and we want to set node integration to true. And once we do this, now we've told our main process that, hey, inside our web, which is our render processes, we want to integrate to node. We want to have access to node inside our render processes. So now remember, we modified our main process, and anytime we modify main process, we have to start this server here. So I'm going to go ahead and save this, come back to my terminal, and then Control C to stop this. And I can even clear everything I have here by writing clear. And you can use, if you're on Windows, you can use CLS to clear. And now run npm start again. And this should start our application. And hopefully, we shouldn't get any require error again. And we can see the require error is gone. So now we have access to our node. And now at this point, whatever text I write here, this is a text. Whatever text I write here, if I click on save, this is what's going to happen. First, it should call the save text function. We should get the value of our text area and then log it to the console. So that means that we're going to see the value here. And then it's going to send that text to the IPC main by using IPC renderer. And inside of IPC main, whenever that text gets sent, we log that text, which means that it's also going to be logged here. So when I click on send, we should see the text here and also here. So I'm going to click on save, and we see it here and here just as expected. I click on it again, we see it here and here. I can change the text. This is a text and it's good. Click on save and we get it here and here. So that means that we've been able to successfully send data from our renderer process to our main process. So I'm going to pause here. In the next session, we'll look at how to write this data to a file on our PC. Hi, so in the previous section, we were able to log the text from our renderer process, which was sent using the IPC renderer, to our main process. We're able to log it in the terminal. So in this section, we are going to look at how to write whatever value, whatever data we get to the file, to a file on our operating system, our PC. Now, to do that, we are going to look at one model that comes with Electron, with Node actually. It comes with Node actually, it doesn't come with Electron. And since Electron uses Node, we have access to all the libraries and all the APIs that comes with Node, and all the models that comes with Node. So we are going to look at one model, one API that comes with Node, which is called FS. So I'm going to go to Google and then make a quick search of Node FS. And then this should give us a link to the Node FS documentation. And FS is short for file system. Now, when you open it, we can use this file system to do a lot of things when it comes to working with files. A whole lot of things. But what we want to do is write file. So we're going to look for this FS write file. If you can't find it, you can use Control F or Command F, and then you can search for write file. And this should get you to where write file is. And just click on that FS write file. And this should bring you to the documentation of FS write file. Now, this tells you about everything about FS write file. But down here, it shows you how FS write file can be used. So basically, once we import FS, we can use FS and then call write file function on it, pass it the name of our file, give it the data we want to write to the file, and then it returns an error if there was an error. That's basically what it does. So let's go ahead and use it, and then we can see how this really works. So back here, since FS comes with Node by default, we can easily import it by creating a variable for our FS and then using require and then requiring FS from Node. And once we do this, we've required the FS, and it comes by default with Node, so we don't have to install it. So we've required the file system, and then we have this as FS. So over here, when the text is sent, well, aside from logging it to the console, we can use FS, and just like we saw in the documentation here, call write file to it, give it the name of a file. So we can use FS, call write file, and then we can say, well, we should write to a file called, what should be the name of this file? Okay, let's call it test.txt. no, I think text is too short. Let me just call it sample.txt or sample file.txt, and then the next data we pass to it is the data itself, which is the text that we passed here. So we pass it the text, and then the next data, or the next thing we pass to it is an anonymous function or an arrow function that accepts the error if there was an error. So we pass it the error, the anonymous function, and over here we get this error. So we are going to get, let me just align this well. Good. So we are going to get this error if there was an error writing to the file. So but we can listen to that, we can handle that. We can say that if there was an error, let's just log something. So let's just go ahead and log console.log there was an error, and let's just add the error to it. So if it was an error, nothing will happen. We are just going to log it. Else, if there was an error, we are going to log the error. So we've handled that part. Else, what do we want to do? Else, let's go ahead and let's just log file has been saved, just for now. For now, let's log console.log file has been saved. So let me just go over what we are doing over here. So first and foremost, we are using the file system API or module that comes with Node, and we are saving it as fs. We are requiring it as fs, and we are calling write file on our fs, giving it the name of the file, the text that we want to write to it, and passing it an anonymous function to handle the response. So the anonymous function passes the error, and we are saying that if there was an error saved in our file, we want to just log there was an error. Else, we want to log file has been saved. So let's go ahead and let's save this. And remember, anytime you modify your main process, you have to restart this. So you can stop this with Ctrl S, start it again by running npm start, and this should start our node application or node model for us, our Electron application for us, sorry. So now whatever we write here should, and whatever I write here and click on save, it should bring us to our main process and then write it to a file for us. So let's try that. So this is another example. So let me just write this. This is another example. Now once I click on save, let me just pull this up here. And this file here is not going to save, is not going to be saved on our desktop or in our documents folder. It's going to be saved in our project folder, the text app folder, because we didn't specify any path over here. We just give it a name, so it's going to save it here inside our text app folder. For now, we don't have any file here, so I'm going to come up here and let's notice the change here. Once I click on save, hopefully it should create a new file here for us. So I'm going to click on save, and then once I click on save, you can see sample file.txt has been created for us. And when I open this, let's see what we have in there. We have, this is another example in there. So I can put in another content. This is another example, and it has been edited. And once I run this, I click on save, the content of sample file would be updated. So let me open it again and let's see. I open it, we have the new content inside our sample file. So we've been able to take data from our render process, and we've been able to save it in our main process. So I'm going to pause here, come back in the next section, and look at the best way to specify the location of our file, since currently it's only being stored inside our sample file.txt. Hi. So in the previous section, we were able to write the content of our text area here to a file. And we have the file here, sample file. And also we got our log in our console telling us that the file has been saved. So, well, everything is going on pretty much well, except for one thing. Whatever file we create is going to be saved as sample file and is going to be saved in our text area folder, which isn't exactly what we want. We want to allow the users to choose where they want to save the file, and we save it there for them. That's just what we want. we want to give the users the liberty of choosing where they want to save the file. And with this, we are going to use one of the APIs that comes with Electron called Dialogs. So let's go to the Electron documentation. So you can get to the official Electron website, which is electron.js, and make sure you click on Docs up here, and this should bring you to the Electron documentation. Now, down below API reference, there is a reference to dialog. Now, if you can't find this, you can use the search bar and you can search for dialog, and you should see dialogs over here. You should see dialog here. So, but if you can find it, you can just scroll down to under API reference. You can see dialog, and then you click on it, and this will take us to the dialog documentation. So there are so many kinds of dialogs that comes with Electron. There is show open dialog, there is show save dialog, show message box, and other dialogs over here. Now what we want to do is to show save dialog, and what this save dialog does is this: when this dialog shows up, and the dialog is, let me see if I can show you an example of a dialog. So when I do Command S, okay, this is a simple example of a dialog. This pop-up you see here on Windows, when you try to save or do a download, or when you type Control S on Windows or Command S on Mac in the browser, you get the dialog which asks you to choose where you want to save the file. And this is the save dialog we are talking about. So what this does is, as soon as you pop up a save dialog, and let's say I do Command S and I choose desktop and I enter the name of my file as let's say DDD, and I click on save, this dialog doesn't really save anything. All it does is returns the path where the file has been saved to, the location of the file. All it does is returns the location. So it returns my desktop / ddd.html so in this instance is Chrome. So it returns it to Chrome, and Chrome will go ahead and do whatever it wants to do with this file. So Chrome will go ahead and download this page and then save it in this file and add whatever it wants to add to it. That's basically how it works. So we are actually going to see it in action very soon, but then we are going to be using this dialog.show save dialog to tell our users, to show our users how to save. So to do that, way back up here, it says that we can use dialog by destructuring it from Electron. So back here, come over here, back into my application. Now we can destructure it from our Electron. So I can bring a comma and then add a dialog. So destructure dialog. Now we have access to the dialog, and we want to pop up the dialog when the user wants to save. That's exactly what we want to do. So at this point, I'm going to go ahead and remove this console, log in the text value because we don't really need it. And just like in the documentation, back here, down here using the show save dialog, it says that we can use dialog.show save dialog, pass it the browser window where we want the dialog to be popped up on. And the browser window, mind you, is your renderer process. And we can have more than one, like I said previously. So we have to pass it which window we want to have the dialog showed on. And it takes some options, and these options are here: the default name, the title, and some default parameters which we are going to look at. And also it takes a callback, and the callback is what happens when the save is done. So we're actually going to face a simple error here, and we could have resolved it very earlier on, but I just wanted us to get this error so that we can see how we can solve it. Not really an error, but it's going to be kind of a challenge. So let's go ahead and then let's use this dialog.show save dialog, and then let's see what I'm talking about. So back in here, back into my code, we are going to write our save dialog code, or we are going to show our save dialog right when the user wants to save. That is when IPC on save is instantiated. So we've imported our dialog. So we just use it by using dialog.show save dialog. And first and foremost, we have to pass it the browser window. And our browser window is this win over here. Now, there is where the challenge comes in. Our win has been defined when the app is ready, just in here, which means that we have access to our browser window only inside Up on ready. Now here lies the case we want to use it inside IPC main on save. And well, when we try to use this window over here as our browser window, try to pass it this win here, there's going to be an error because win at this point is not defined. Win cannot be accessed in our IPC main. We see when I hover over win here, it says win is electron.browser.window, but over here it says win is any. So win over here doesn't exist. Now this problem over here can be solved by making our window a global variable up here, so that it can be accessed anywhere inside our main process. So let's go ahead and let's do that. So I'm going to put our let win declaration up here, and then down here we're just going to set that new win we have to our new browser window. That's basically it. Then now we can have access to our win here in over here. Now we can see let win references this let win here. Win here references this let win. So now that's the issue I was talking about, and now we've been able to fix that. So back to our show save dialog. First it takes a window, a browser window, and the second attribute that needs to be passed to it is our options, and this is the options over here, which is an object. So we can pass it a title, default path, a button label, and all this stuff. Now all we need from this is the default path, and the default path is kind of the default file name that should be used. As you can see, it says the absolute directory path, absolute file path, or file name. So this is the default name that we want to be there when the user tries to, when we show the save dialog. So over here, the second parameter here is going to be an object, and let's set the default path, which should be our default name. And we can see the default name for our file should be filename.txt. We are going to see where this one is going to pop up very soon. Now the third attribute that gets passed to it is the callback. So the callback is the function that gets called after everything here runs. So back into our code, we put in our callback, which is going to be an anonymous arrow function, which we have here, and the callback gets called with the full location of our file, the location that the user selected, whoever they wanted to save the file. After the show save dialog was popped up, it returns the full location of the file. So this one over here is the full path of our file, and for now let's just go ahead and let's log our full path when the dialog is shown. So let's put in a console.log, and let's log our full path for now. So I'm going to go ahead and then comment writing the file, comment that code out. So as soon as save is called, we don't do anything with the file. We are just showing a dialog, and then whichever location the user selected, we are going to log that location to the console. So let's see how that turns out. So I'm going to save this, come back to our processor, main process, because we've edited the main.js, stop this, Control C, and then start it again. And then once we start this, and then we come in here and then we write a file, a text. Let's say this is a text, and I click on save, we should see a dialog. So I'm going to click on save by clicking on it, and we see a dialog pops up, and this dialog here pops up with the default file name that was specified, as you can see right here. So this dialog here pops up with the default file name, which was filename.txt, and you can see that was what we specified here. So whatever default name is specified here is what's going to be in the field by default. And okay, let's say I want to save this on my desktop. So desktop is selected by default. So I click on save. As soon as I click on save, this is only going to return the full path to our file for us. So it's going to have user my name / desktop / this file name. If you're on Windows, you're going to have C users, your username, desktop / file name, if you are trying to save it on a desktop. So I'm going to click on save, and back to the console, we should have the full path log, as we can see from here. So we have user, Mubarak Awal, desktop, and then the file name, and this is where we want to write the file to. So this is exactly what we want. Once we get this file, we can tell our FS to write to this particular file over here. So that is basically what we want. Now I want you to notice something. If I click on save, Let's try this again. If I click on save and then pop-up come and I just cancel without doing anything, we get undefined return. So we have to be very careful how we use this. So we have to make sure that whatever full path got returned is not undefined. That's basically what we want to do. So over here, what we want to do is this. Let me go ahead and remove logging it. We want to check if there was a full path that was returned. So if there is full path, so if full path, they want to go ahead and then write to that path. It's as simple as that. So I'm going to cut the code for writing to file, paste it in between here, and then uncomment it out. Uncomment it, and then we have it here. So now we want our show dialog to show a dialog, users to select a location, and once we get a full path, we want to write the file, the data to the full path. That's what we want to do. So I'm going to save this, and we've edited our main process, so I'm going to restart my main process by stopping this and then starting it again. And this should give us our new process. And this time, when I write a new file, let's see, this is a new file. When I create a new file and I click on save, it should give me the dialog. And this, I want to save it on my desktop, and I want to call this electron.txt. Now, once I click on save, this should save whatever content I have inside my desktop and name it electron.txt. So currently on my desktop, I don't have any electron.txt, as you can see here. And let me open it from this side so that you can confirm that. So this is my desktop, there's no electron.txt. Now back here, I'm going to click on save, and this should create a file on my desktop. So back to my desktop, we can see electron.txt has been created this time. And that is basically how the show dialog is going to work. So when I click on save again, it's going to ask me to resave it, and every time I click on save, it's going to pop up the show dialog. And that's kind of not how we want it. Realize when I click on cancel, the app didn't crash because we handled it if it's undefined. Now, anytime I click on save, this pop-up comes, and that is not exactly how we want it to work. We want this pop-up to come only once when we are saving the file for the first time, and the second time and the subsequent times, whenever I click on save, we should just save the file without bringing this pop-up. So we are going to pause here, come back in the next section. I know this has been a very long video, but we are going to pause here, come back in the next section, and we are going to look at how to address the issue of not popping this up anytime save is clicked. In the previous section, we got our save button working, but the problem currently is that the save button brings up the save dialog anytime the save button is clicked on. So it doesn't matter whether this is the first time or this is the last time or this is the second time. Anytime we click on save, we get the save dialog coming up. So that's what we are going to fix in this section. So in this section, we are going to make sure that this save dialog here comes up only the first time the save button is clicked on, and afterwards this dialog doesn't come up again, but then goes ahead and just saves the file. So let's go ahead and let's see how to fix that. So currently, whenever the save button is clicked, so back to my renderer process, whenever the save text is clicked, we send a message, we send the value of our text area, we send the data as through IPC to our main process as save. So in the main process, we accept that save, and whenever we get the save event, we start a dialog, and that's what we want to do. Now, whenever we get a save event, we want to check if we've already saved a file previously. If that's the case, then we want to just go ahead and then do this code over here by just writing the file. That is if we already have a save dialog. If this is the first time we are saving, then we want to go ahead and then show the save dialog so that the user can choose where they want to save the file. So in order to do that, the best way to do that is to track whether we currently have a path that we are saving the file to, or we don't have the path that we are saving the file to. So I'm going to create a global variable here called path, and this variable over here is going to, or let me just call it file path, and this variable over here is going to be by default undefined, and this path is going to keep track of the path to our file. So it's going to tell us whether our file, our current Electron state over here has a file path or not. So whenever the save button is clicked, we want to check if file path is undefined. If it's undefined, then that's the first time we are trying to save. So we're going to go ahead and then show this dialog box. But if it's not undefined, they want to just go ahead and then save whatever data was sent to this file path. So let's go ahead and let me show you what I mean. So in here, instead of just showing this dialog box whenever IPC on save is called, we want to put in an if else statement here. So we want to check if our file path is equal to undefined, then this is the first time we are running this save. So we want to go ahead and then do all this only if it's undefined. So put this inside our if. But if it is not undefined, then that's our else. Then we just want to go ahead and then write the text, which is using this code here, the code for writing. So this code we have here, let me format it well so that it looks nicer before I copy it. Okay, so this is it. So this is the code for writing file. We are going to come back to this if statement in the mix and changes here. But then if our file path is equal to undefined, then we want to show a dialog box, and whatever full path we get, we want to save it. But then we also want to set that full path to our file path. So we want to go ahead and set the full path, the file path, to be equal to our full path over here. So this was going to happen. The first time it runs, our file path is going to be undefined. So dialog box is going to, the save dialog box is going to pop up, and it's going to try and then save our file for us from the path that was selected by the user. So we get a full path, and then with this full path, all we do is we set our file path to be equal to the full path. So whatever full path the user selects, being it on the desktop, in the downloads folder, wherever they select, we set that to our file path. So this file path is going to be set the first time the user clicks on save. Afterwards, this if here is going to be false. So this here will not run. The else is going to run because our file path will no longer be equal to undefined. So with that, if our file path is no longer equal to undefined, then we have a file path. So we want to go ahead and then still write again, but this time we want to write with our file path. We want to write to our file path instead of full path because we don't have access to any full path in here. So we put our code for writing in here, and then we change the full path to file path. And we can even do the same for this. We can just change this full path also to file path. And now we have our code running. Like we have our code which is supposed to work. Now when you look at this, there's something wrong here. We have the same code repeated twice here. So I'm going to create a function which is going to be write to file, and this function is going to be like this function is going to be this. It's going to be exactly like this, so that we don't have to rewrite the same code twice. So down here, I'm going to create a function, and I'm going to call this function write to file. And since this function is going to be writing to this file path here, and we have it defined globally here, we don't have to pass any file path here. But the function will need to know the data it wants to write to it. So it needs to know the data. And this function is going to be just like the code we have in here. So I'm going to copy this and paste it in here. Now in here, the data is going to be, we're going to replace this text with our data, because in here this fs write has no access to this text. It's only the data we have here. So I'm going to put the data here, and our function is complete. So now we can just go ahead and call our write to file function here and pass it the text. So I'm going to replace all this with the call to write to file, and then pass it the text that we want to write to the file. And I'm going to do the same for this too. I'm going to call write to file, and then pass it the text that we want to write. And now our code looks cleaner. So I'm going to save this, and we're going to try it and see if the write to file, if the save dialog shows up only the first time we try to save. So remember, anytime we modify the main process, we have to restart our running process. So I have to come here, stop this, and start it again. So I'm going to stop it, and I'm going to start it again by running npm start, and now it comes. So I'm going to try and then save a file. So this is a file. Now when I click on save, I get a dialog box just as expected, and I'm going to call this file. Now when I click on save, this should save the file. As we can see here, file has been saved. Now when I click on save again, hopefully we shouldn't get the save dialog. So I'm going to go ahead and click on it, and we get file has been saved without the save dialog coming up again. I'm going to click again, and we can see without it doesn't come up again. I can modify this to this is a file and it's good. Click on save, and it still saves without bringing me the pop-up or the save dialog again. So this is exactly what we want to achieve. So we're going to pause here, come back in the next section, and continue with our app. So now we have our file saving, and our save dialog is showing up only the first time we click on this save button here, and with the subsequent times the save button is not showing. That is exactly what we want. Now in this section, we are going to look at how to send data from our main process to our render process, mainly because currently our render process here has no idea whether the file has been saved or not, because we are doing all operations regarding saving file inside our main process, and we are currently logging file has been saved if it's saved successfully. And what we want to do is that we want our main process to notify our render process whether it was successful or not, so that our render process here, well, we'll have an idea what is dealing with. And also we'll be able to show a message somewhere here, maybe somehow notify the users that, hey, the app or your text has been saved successfully, something like that. So to do that, we have to learn how to send a message from our main process to our render process. Now, sending message from render process to main process, we use IPC render.send. Now, you might be thinking that we are going to use IPC main.send to send from main process to render process, and that isn't pretty much it. This is mainly because you can have more than one render processes, just like that you can have more than one tab in a browser. And to specify which render process you want to send the message to, or want to send the data to, we use the process itself. So we are going to use our win process, or our render process, which is win, and that's what we're going to use to send the message. And to do that, we use our win. So down here, aside from login file has been saved, we also want to use our win, and then we call web content on it to access the web content. And once we have access to this web content, this win.web content is just like IPC main, but then for just this win only. Now we can call the send on this just like we call send on our IPC renderer, and this is going to send whatever data we pass here to this window over here. And this window over here, remember, is loading our index.html, which is this here. So in the end, it's going to send whatever data we pass it to this guy over here. Now back here, we want to send this data. Let's just call this saved as file saved, and we want to send in a status whether it was successful or not. So over here, we can say, okay, send in success. So this is this line of code here is going to send this string here, success, to our index.html, and the message is going to have this tag saved. So now we can save this, and back inside our index.html, we can now listen. We can, just like the way we did IPC main on over here on save, we can do IPC renderer on saved, because this time we are calling it saved here. So we can do IPC renderer on saved here to listen to this saved message whenever this saved message is sent. So we can come here, and then down here we can do our IPC renderer dot on. Then we can say whenever someone calls a saved, and just like the IPC main, it gets the event and the data that was passed to it. So the first one is the event, and the second one is the data that was passed to it, and I can call this status, or let's just call it results. Now this over here is an anonymous function. So whenever IPC receive this saved, what do you want to do? Let's just go ahead and let's log something for now. So let's console.log and let's log for now. Let's check if, let's make a quick check here. If our results is equal to success, then that means that we successfully saved the text. So let's just go ahead and console.log a success message. So I can say note saved successfully, else it wasn't saved successfully. So let's just go ahead and let's save. Let's log console.log. What message should we even log? Okay, let's log error saving text. Right, so this is very simple. Over here we are listening to the save, and whenever we get the save, we are checking if the results that was passed to is equal to success, then we are logging note saved successfully, else we are logging error saving text because there was an error. So now let's go ahead and let's start our process by stopping this and starting it again. And now let me go ahead and open my developer tools here, and let's try logging something. So this is a text. Click on save, and we get this is a text logged over there because we have it in here. We have it here. We are logging the text here, so that is why we saw that this is a text logged here. So when I click on save and I cancel, realize that we get nothing here because it hasn't been saved yet. When I click on save and I give it a file name, let's say AAA, and I now click on save, now we get note saved successfully. So that means that our main process here is sending a message to our renderer process successfully. That is how come I getting the note saved successfully in our renderer process, just like what we have in here. So this is pretty good. Now let's pause here, come back in the next section, and then let's try and make this more user friendly by not just logging stuff here, but then making it, well, a bit nicer. Thank you. Now we are sending a message from our main process to our renderer process. So what I'm going to do in this section is to, well, instead of logging something here, whenever the user clicks on save, the user won't be seeing this console. So it's going to be something like this. And when they click on save, we want to somehow show them something here so that they know that it has been saved successfully. And in my case, I just want to change the background to green if it was successful, and change the background to red if it wasn't successful. You know, just a quick animation in there. So, and it's going to be for like, let's say 5 seconds, or let's say a second. So just change the background to green for a second if it's successful, and then change the background to red for a second if it failed. And to do that, back in here, if it was successful, that is if results is equal to if results is success, instead of just doing console.log and logging the note, what we want to do is set the background of our text area, and we have access to our text area already here, text area. So we can do that by calling our text area and then calling the star attribute on it, and then calling the background color. So we can say text.star.background color, and we want to set this background color to green, and I have a light shade of green, which is hash B2FF99. So you can use this. This is a very light shade of green. So if it was successful, we want to change the background color to green, else we want to change it to red. So it's the same thing, but I want to change the text area. We want to change the text area's background color to red instead of green if it failed. So background color, and I have a light shade of red also here, which is hash FF8989. So we have this. So if it's successful, we want to change it to green, else we want to change it to red. Now this is going to change the background color until it's going to make it red consistently until we set it back to nothing, to white again. So for now, bear with me, it's going to be green and it won't go off. We are just going to add one line of code in a while, in just a few minutes, which is going to reset the background color again. So for now, let's come here. Since we've modified our renderer process, let's refresh our app's user interface here by clicking view reload, or control R on Windows or command R on Mac. And then now when I enter any new text here, this is a new text, and I click on save, we get the background color changed to green, but it looks like it's green and it's not going, it's still green. So when I click on save again, I don't really notice whether it's saving or not because it's still green. So we are just going to use JavaScript set timeout to run a piece of code after a timeout. So down here, we are going to call set timeout, and I'm going to explain what this is doing. And set timeout is going to take two parameters. The first parameter here we are going to pass here is going to be a function, and the second parameter here we are going to pass is how long it should take, so how long before running. So this is what we are going to do. We are going to pass in a function here which should run, but we are going to specify how long it should take before these functions run. So it's like we are setting a countdown timer, and once this countdown is up, the function here will be executed. So what we want to do is that once this countdown is up, we want to set the text area's background back to, well, white, or back to nothing. We just want to clear it. So over here, let me just specify how long before this code here, this function here should run. So it should run after 100,000 milliseconds, and this is in milliseconds, not in seconds. So 1000 milliseconds, which is equal to 1 second. And over here we need a function, so I'm just going to pass in the function, which is going to be an anonymous function, and this function here is going to run whenever after 1 second. So what do we want to do after 1 second? We want to set the text area, we want to set its style and background color. We want to set this back to an empty string. So this is what we want to do after that 1 second. So let's save this, come back here, refresh this, and then let's try it again. So this is another try or whatever. I know this doesn't make sense, but let's try it with this. When I click on save, it comes for 1 second, and then we see it vanishes. Click on save, and then it vanishes. Save, it vanishes. Save, and this is pretty much what we want. So now we have a very cool animation showing in our app, and well, our app is working just as expected, and our users are really going to be happy with what we have so far. So I'm going to pause here, come back in the next section, and continue with this app. And now we are going to move to something more interesting. We are going to look at how to add menus to our Electron application. So the default menu that comes with our Electron application is this one here: File, Edit, View, Window, Help. If you're on Windows, you are going to see just these 5 menus here: File, Edit, View, Window, Help. If you're on Mac, however, you're going to see this extra seat one here, which is default on Mac. It's actually the first menu that exists on every application or every desktop application that runs on Mac. So that is why you are seeing this first one here on Mac. But if you're on Windows, you wouldn't see this first one here. You see File, Edit, View, Window, and Help. So we're going to look at how to create our own menu. And to do that, I'm going to explain to you how menus work in Electron. So I have a quick slide here to help me do that. So in Electron, we have menus, and this is just a quick label of a quick menu that we might be familiar with. So File, Edit, View, Help. Now this menu over here is sometimes is like the most common menu we see in most of the apps we work with. And in Electron, each menu, as you see, for instance, when you click on File, you get the sub menus under File. When you click on Edit, you get the sub menus under Edit. When you click on View, you get sub menus under View. You click on Help, you get sub menus under Help. In Electron, the name you see over here is what is called the label, and what you see under the label is what we call the sub menu. So every menu has a label and a sub menu, a label and a sub menu, a label and a sub menu. See, they all have their own labels and sub menus. And this whole thing over here is an array of menus. That's basically what it is. So one big array which has an object, this one object here with a label and a sub menu, another object with a label and a sub menu, another object with a label and a sub menu, and that is how it is for every menu item you add to your menu over here. So let me show you how that looks like, and we're going to look at a simple menu from the Electron documentation. So back to the Electron documentation, I'm going to scroll down to under API reference, scroll down to menu, and when I click on it, it should give us a simple documentation on the Electron menu. And when you scroll down, there's a layout of the menu we see up here when we launch our Electron app. So this menu we see whenever we launch our Electron app. If you're on Windows, you're going to see it up here, so don't worry if it's up here. So the menu you see, this is the code for showing that menu. So this is the code for the menu you see up there when you launch your Electron application. And basically it's a list of objects. So you can see the whole thing is one big list that starts from here and then ends here, a big list. And inside the list we have objects. So this is one object specifying one row. There is another object, and you can see it has a label and a sub menu. This is another object which has a label and a sub menu. Another object which has a label and a sub menu. Another object which has a label and a sub menu. So basically it's just one big list with objects. So let's create a list of let's create a menu of let's create a menu that has a file, so that we can just click on file and then click on save to save. And also probably it can have this edit with a copy, paste, cut, all this. So let's create a menu with these two, file and edit, on our own from scratch. So to do that, back into our code, in the main process, we are going to create an array which is going to represent the template for our menu, and we are going to look at how to use that in a while. So I'm going to create an array, and it's going to be a constant, and I'm going to call this menu template, and this is going to be a list or an array of objects. It's going to have first object to represent one menu, another object to represent another menu, another object to represent another menu, and each object is going to have a label and a sub menu, just like we saw in documentation and from the slide I showed you. So our first object is going to be come over here. It's going to be the file, like we said. So when we launch our app, we want to show them the file, and when they click on file, we want our users to see a save button so that they can save from there instead of clicking here. And they can also click on, maybe let's add a save as button, so that if they want to resave this as a different file, they can click on the save as to resave the text again. So it's going to have two labels, a save and a save as. So back into my code, remember it's supposed to have a label. So we are going to have a label, and this label is going to be what we want to see up here. So it's just going to be file. So I'm going to set our label to file, and below our label is our sub menu. And our sub menu, small m, our sub menu is going to be a list of the sub menus that we are going to have. And our sub menu also have labels, and also when they get clicked, things that should happen. For instance, when I click on file here, this is a sub menu and the label is new file, and when I click on new file, something happens. So our sub menu is also going to be objects. So the first sub menu we are going to have is going to be our save button. So this is going to have a label of save, and when they click on save, what should happen? Whatever is going to be happening when you click on save is going to be defined in a click function that Electron understands down here. So each sub menu has a label and something that should run whenever that label is clicked on. So for now, let's just go ahead and put in a console log. So console.log, and let's just log save from menu, and let's do another label another sub menu for our save as button. So another sub menu, so label save as. And when this one is so clicked, what do you want to do? Let's also, for now, let's just do a console log, and let's log save as from menu, and let's save this. So this is one object, this is one menu item. Now we can put a comma and add another menu item. So another object, we should have a label, and we said we are going to have a file and edit. So let's look at the edit as well. Now let me just mention this. In Electron, we can have all this edit code over here. You see, undo, do, redo, paste, everything here that is under this edit label here. We can have everything here by adding one single line of code that is defined by Electron and is understood by Electron. So back into the documentation, let me show you what I mean by this. Over here, you can see this is the edit menu that is seen by default when we launch our Electron app. Has a label and all these sub menus here. So we have to write all this if we want to get this edit menu over here. Now, instead of writing all this, we can just put in row edit menu, and that is it. Electron is going to understand this, and this row edit menu is going to work just like everything we have under edit. So instead of writing all the code for edit, let's replace all this over here with just one object, which should have a row, and the row is edit menu, and that's it. Just like we have from documentation, row edit menu, and that is it. This row edit menu here is going to replace everything we have in here. So let's pause here because this video is getting a bit longer. Let's pause here, come back in the next section, and then let's see how we can use this menu template we've created and we'll use it in our application. So in the previous section, we added this menu template here, which is just an array with two objects. The first object is our custom menu item we built that has a label and a sub menu, and the second one is we using the power of Electron to get a whole edit menu. So we're going to look at how to use this menu template in this section, and for now I'm just going to restart my Electron process, and then we are going to see if our application's menu has changed in any way. So I'm going to stop this, start it again, and we can see we still have the default Electron menu up here, just as expected. So we have it up here. Now, in order to change this default menu to the new menu that we have here, our new menu template here, we have to import menu from Electron up here. So as part of the things that destructure, we also have to destructure menu. And with this menu, we are going to be able to replace our default apps menu with the template that we have here. So now we do that when our app is ready. So when our app is ready, aside from setting the file for our window, we also want to create a new menu. And to do that, we are going to create it as a constant, and we use the menu we just imported, and then we call the build from template function. So sorry, let me call this constant menu. We use build from template, and what this does is it takes a template, and Electron is going to take care of converting whatever template we pass to it, which in our case is this menu template here, into a correct menu, into like an Electron menu object. So let's pass it the menu, and our menu is our template. Our template is called menu template. So let's pass it our template, which is called menu template, and now we have a menu built for us by Electron. Now we want to set our applications menu to this. So all we do is use our menu again, and then we call set application menu, and it takes a menu. So we just pass it this menu over here as this, and as soon as we do this, Electron is going to take care of setting the menu of application to this menu over here, which is basically a reference to our menu template which we created down here. So I'm going to restart my Electron process, the main process, and let's see if our applications menu changed from all this to the new one that we have. So I'm going to stop this, start it again, and boom. So we have just edit. Now, if you are on Windows, you should see both the file and edit. And when you click on file, well, and then when you click on file, you see the save and the save as menu, the two menus down there. When you click on edit, you should see all the edit menu that we had previously. So just adding that one line of code, which is row edit menu there, gives us everything under edit. So well, that's pretty much cool. That's pretty cool. So now to the awful problem we have currently, which is somehow interesting. Electron on our application on Mac, somehow we can't find our file menu. We see only Electron and edit. And when I click on Electron, we see the save and the save as menu that we gave for our file, which isn't what we expected, because we called it file. Why is it called Electron? Now, just like I mentioned from this slide here, on Mac, the first item you see here is the application itself. So in every app, for instance, in my Chrome, the first menu I see is for Chrome itself before all my menu. When I come to my Electron app, the first menu I see is going to be for the app itself. So if we are on Mac, I want to set a whole different menu for the first item here. Else, like I want to use the file as the first item if we are on Windows or whatever. So what I basically mean by that is this: if we are on Mac, we want to have an extra first menu which is going to show only on Mac, so that our file and our edit and whatever we want is going to show after the first menu. Else, what Mac is going to do, or what Mac is going to do is going to move this file as a first item here. So in turn, our file is going to be the first item, but then because by default the first item in Electron on a Mac OS desktop application, the first menu is the name of the app, is going to rename this file to the name of our application. So to fix that, we want to have our own first menu here if you are on Mac. Else, we don't want any first menu. We want to have this if we are on Windows and other operating systems. So to do that, we want to come back to our app and we want to have a first menu here. Now let me show you what I mean by that. So down here we have this object. So before it, I'm going to put in another object with just a comma, and this object here is an object we want to have as the first object if we are on Mac. And if we're on Mac, we want the first object to be for our application. For instance, this is VS Code, and the first menu item I see here is code for VS Code. So if you're on Mac, we want to put in a menu here as a first item, else we don't want to put in any menu. And to check if you're on Mac, we can use a simple code that comes with Node itself, and that is this. We can check if, so let me just take off this and take off this, and what we can do is we can check if the process that is running the application, its platform is equals Darwin, and Darwin is the core process that is running Mac OS. So if it's Darwin, then we are on Mac. So if it's Darwin, what do you want to do? So we are going to use a ternary operator here. So if process.platform is equals Darwin, we want to put in an object here. Else, we want to have an empty object. So this is the ternary operator, and let me bring my comma here. So this is a ternary operator. If you don't know what a ternary operator is, you can quickly read on that, and I think you should have a clear idea on it. So if the platform we are running the app on is Mac, then we want to have a menu here. And what menu do you want to have? Now the menu should have a label, and the label is going to be the name of our application. And to get the name of our application, we can get it from app here by calling app.getName, which we have from here. So we can just call app.getName, which is going to be the first label if we are on Mac, And then we can have our sub menus, just like we did for this one's label and sub menu. So this sub menu over here, and we are doing this because we want our app to be supported on both Mac OS and other operating system as well. So for now, let's just put in, so back to the documentation, let's see what we can use from here. So in the doc, we can see there's a similar thing here. If the process is equal to Darwin, then we want to put in something else. So what do we want to do? Okay, we have a menu, so let's go ahead and let's put in just a row, just this row about in our sub menu, and that's going to be this about here, the one we have in our Chrome. So let's put in just row about as our sub menu. So back into our code, we are going to put in a row which is about, and that is it. Now with this, our app is going to be, or our menu is going to be compatible on both on both Mac OS, Windows, and other operating systems. So what we are doing is this: we are checking if we are on Mac, we want to have this as our first menu item, else we want to have nothing as our first menu item, and then we have our second and our third. So let's go ahead and save this, run our app, and then let's see what we have. So I'm going to save this, come back, restart my process, save, and now I have my file showing on Mac OS, and we have our save and save as. If I click on save, we should have the save from menu getting logged, because that is what we have here when save is clicked on. And when I click on save as, let's see what we get. So back here, when I click on file save as, we get save as from menu, just as expected. So this is how to have our menu items showing on both Mac and other operating systems. So we are going to pass here, we are going to pause here, come back in the next section, and then look at how we can get our click buttons here working just as expected, instead of just logging stuff out. And also, if you notice, our Electron menu here has an about, which is for Mac. When I click on it, we get an about just as we want. So we're going to pause here, come back in the next section, and get our save and save as menu items working. Thank you. In our previous section, we got our Electron menu, our menu showing in our application. So in this section, we are going to get our save and save as buttons working. Now we said that whenever we click on save, we want it to work just as this save button here, which means that we want it to take whatever text we have here, and we want it to go ahead, and then we want it to fire, take the text content, send it to our main process, and in our main process, we want to go ahead and write it to a file. Just as our save button is working here, we want our save menu to work. Now, there's going to be kind of a little problem here. Now, when we click on save, we need the value from our text area here, and our text area is in a whole different process, which is the render process. So the problem is this: how do we get our save here, our main process, to go into our render process and then grab the content and then bring it back to the main process? Now we can do this very easily. We can go ahead and then use our IPC to send a message to our render process that the save button has been clicked, and then our render process is going to go ahead and fire this save button for us because we just click on save button. Now let's do it so that you get to understand it more. So to do it, we are going to send a message instead of logging save from menu. We are going to send a message to our render process, just like the way we did it here by using win.webcontent.send. So we're going to come here and we're going to use win.webcontent.send, and we want to send a message. Now let's just send, let's call it save clicked, so that our render process gets this save click text, and what it's going to do is just fire the save text function that we have here, just like what we do when we click on our save button from up here. So we are going to send save clicked, and we don't need to pass in any data because we don't have any data to send, so we can just send it save clicked. And back into here, now we can configure our IPC renderer to listen to save clicked. So back here, we can set our IPC renderer and we can call on save clicked. So whenever save is clicked, when you receive that save has been clicked, we want to call an anonymous function. And what do we want to do? Whenever save is clicked, we just want to call this save text function we have here, because this function is going to go ahead, get the text value for us, and then send it. You know, we've already done everything before. We've written the logic for making our save text, our save button work. So we just have to call the save text function here. So we call our save text function. Whenever IPC on save click is called, we want to call our save text function. So this was going to happen. Whenever we click on save, it's going to tell our web content, our render process, that save clicked has been clicked on or has been fired. And whenever our render process receives the save clicked event, it's going to call the save text function, which is going to go ahead, get the value of our text, and then tell our main to go ahead and save that text, just as expected. So let's restart our process and then let's see if this is going to work. So I'm going to stop it, start it again, and I'm going to click on the file, save, and let's see if it works. Well, it works just as expected, and we are getting this save dialog come because this is the first time we are clicking on the save button. So this just like the way when we click on this save button the first time, we get the dialog. So it works perfectly. So let me try this. Save. Let me call this as menu save. Save. And we have everything working as expected. Our background changing as green. I can click on this, click on save again, and it works just as expected. So now let's go ahead and let's work on our save as button. Now our save as button is supposed to do the same thing as our save button, but then just that it's always supposed to launch our save dialog. So no matter what, whenever the user clicks on this save as button, they are supposed to get the save dialog, so they choose a location for the text. So back into our main process, whenever save as button is called, we can do two things. We can solve this very simply. Back into our code here, our dialog box here is shown only if our file path is undefined. So why don't we just set our file path to undefined whenever save as is clicked, and then we just tell our web contents to fire save clicked, just as we did for our save button. Now let me show you what I mean by that. So I'm going to delete our console log here, and down here I'm going to set our file path back to undefined, and then just as we did here, we are going to do the same thing here by telling our render process web content to send a message, and the message is that save has been clicked. So this was going to happen as soon as we set the file path to undefined, and then we tell our render process that save has been clicked. The save clicked here is going to fire, and it's going to call save text. So as soon as save text is called, which is here, we are going to get the value, and we are going to send to our render process that save has been, we want to save, and we pass it the value. So in our render process, save here, ipc.onSave is going to fire, which is this here. And as soon as it fires, it's going to check if file path is undefined. And remember, we set it to undefined here. So this is going to be true, and the dialog box is going to show. So anytime we click on the save as, we are setting the file path back to undefined for this over here to fire. So let's save this, and then let's go back to our console, stop it, and then start the server again. So now back here, I'm going to write something here. So the first time, this is a text, and then I'm going to use the save menu up here. I can use edit, select, or edit, copy. Before you come to the edit, let's focus on the file. So I'm going to click on file, click on save, and when I click on save, just as expected, whenever we click on save the first time, that's what's going to happen. So we click on save, this is the first time we get our dialog, and let me call it SSSSS, click on save, and we have our file saved. Now I can click on save again, and it's going to save our file. I can go ahead and I can write more text here. Let me just put in some random text in here. Click on file, save, and it works as expected. Now if I go ahead and I click on the save as, we get a dialog box again, just also as expected, asking us to choose a new file name or a new file location, and I can use, let's say, Zo. Click on save, and it works as expected. Our save button here also works. Our save still works, but anytime we click on save as, we get the dialog box coming up, and I can save it as anything I want. Let me say file name 3, save, and it's working as expected. So we have our Electron app working, and our save and save as menu also working. I can select all this. Let's try our edit menu. I click on edit, click on copy, and when I come back here and then I click on edit and I click on paste, it should paste what we copied. Then we have it pasted. Click on edit, paste, we have it pasted. So our menu is working perfectly, just as expected. Now I'm going to pause here, come back in the next section and continue with this app. So now we have our menu working, the file, save, save as, and then edit menus here working. In this section, we are going to look at how to add the keyboard shortcuts to our menu. So you can see over here on the edit, we have Command X, Command C, Command V, Control, Shift, Command V as shortcuts for all these menu actions here. If you're on Windows, you should see Control for all these menu actions here. So we are going to look at how to add these shortcuts to our menu, the ones we just created here, so that we can just use Command S to save on Windows, which is Control S, and we can use Command Shift S or Control Shift S for save as, to make our work easier. Instead of just always coming here and clicking these buttons here, we are just going to use the shortcuts to save and then save as, just as these ones here. So let's go and then check out the documentation and see if we can find out how to do that. So in the Electron documentation, scroll to adding features to your app. Under that, you can see keyboard shortcuts. So you click on keyboard shortcuts, and you are going to see some examples of adding shortcuts to your Electron application. And as we can see here, to add a shortcut, we just need to add this accelerator option here, this accelerator here, and then we give it the shortcut that we want, whether control or command or whatever we want to use it for. We pass it here. So that is how to add a shortcut. And you can see this accelerator is command or control P, and yeah, basically that is how to add the shortcut. So let's go ahead and let's add a shortcut to our save and save as button. So back into our code, scrolling down to our save, we can add an accelerator by just adding the accelerator after our label, or it can be before or after, anywhere, but then it should be inside the sub menu for just the sub menu action that we want to add the shortcut for. So accelerator, and we want to set this to either command or control S. And back into the documentation, we can see we can do CMD or CTR, which is short for command or control. So we can do CMD or CTRL, which is command or control, and we can just add plus whatever we want. So let's say plus S, and command plus control S is going to command or control S is going to save, and we can do command or control plus shift plus S for this one down here. So just add accelerator, and we can do command or control plus shift plus S, and this is going to give us the command plus shift plus S if we are on Mac, and then give us control plus shift plus S if we are on Windows or other operating systems. So, and mind you, we can use any key we want here. We can use control, we can just use control over here without command or. We can just use command also here without the control. We can use command or control. We can use option. We can use the ALT. We can use any key combinations that we want here. We can even add +S, +A. We can do as many combinations as we want for our accelerator. So let's save this back into our app, our process. We are going to stop this and then start it again. And then let's see if this time it's going to show. So when I click on file, now you can see I have Command S and Command Shift S as my shortcut here. So I can do Command S here, and we can see it works just like me clicking on the save button. And I can do Command Shift S, and it also works just like me clicking on the save as action here. If you're on Windows, you should be doing Control S and Control Shift X. So our menu item is working. But then you notice that, and I think you've noticed this for like a very long time now. But then you notice that the view menu here, which shows us the console for our render process, isn't showing. And this is because we are creating our own custom menu. So if you want to add that, we can just go to our Electron documentation, go to menu, which is down here. That is under API reference. I'm sorry about it. Under API reference, we go to menu, and then you scroll down to the menu that defines our developer stuff, which is row view menu. So we just add this row view menu to our menu items, and we are going to have access to all the stuff that we need as developers to work on our Electron app. So I'm just going to add this row view menu as part of my menu in my application. So back here, aside from adding row edit menu, I can have row view menu, and that is it. Just adding this is going to give us everything here. That's the toggle developer tools, the zoom in, zoom out, reload, force reload, all the things that we need to work on our Electron application. And Electron has all these rows defined in our application. So we have a row if you want to delete something. We have a row for quit if you want to add a quit. A quit menu to application. There's a row for quit. There's a row for separator. Electron has a lot of rows defined, which you can add in any part of application to easily get a menu item. So you go more into this documentation, and then explore more with the menus and see if you can build anything awesome with that. So back into my app, I have this row view menu, so I can stop my process, start it again, and we should have the view menu showing. And from here, I can toggle developer tools, which should give us this. I can hide it back, I can reload, I can force reload. So everything that works here, that works for our developer tools, is back here. And if we are going to publish this to as a live or package this and get users installing it on our desktop, we wouldn't want them to have access to this. So we'd have to take off this menu before we package it. So yeah, that's it for this section. Thank you very much. Hello, and we've come to the end of our very first Electron application. Now, in building this app, we've covered a lot of information. We've learned a lot about Electron, and I believe by now you are confident enough to build your Electron applications. So we've looked at starting all the way from npm, creating a new node project. We looked at installing Electron. We looked at talking about our renderer process, our main process, creating the renderer process, creating the main process, starting our very first Electron app, all the way to talking about Photon, which is the UI library we used. We used Photon to build the user interface of our application. We looked at how to send data from our renderer process to our main process, and even how to write that data to a file. We even looked at how to add a save dialog and also how to send the data or a response from our main process back to our renderer process, which is very interesting. Now, aside from all that, we also looked at how to add menu items, add menu to our Electron application, customize our menu, and even add shortcuts to our menu, which was very interesting for us, and we learned a lot about Electron by building this simple note or text editor application. It looks very simple, but then this app is basically the app we see on most of the operating systems that we use, being it Windows, being it Windows, Mac OS, Linux, whatever operating system you use, there is a text editor that looks kind of similar to this. So we were able to get started from scratch, from a level where we knew nothing about Electron to a level where we've been able to build a complete text editor, which it looks pretty cool. And we can text this. I can write text here. This is a text, and I hope you enjoyed building building this app. And I can click on save, and we have a save dialog, and I can call it app 1 save, and we have our background changing to green because it was successful. And this has been a very amazing experience. And also I'm going to give you a link to the source code for this application, so you can find the link below. That is the link to the source code of this application, or you can find it in the instructor notes below. Either ways, that is the link to the app, to the final code of the app, so you can always go back and refer to the link to the final code of the app if you have any issues. And also don't forget to reach out to me in the discussion forum whenever you have any errors, or you get stuck, or you need help, or you have any questions. Don't forget to reach out to me. We are going to look at packaging this app into Windows executable and Linux packages and Mac applications. We are going to look at packaging this app and then distributing it to other operating systems in a future section. But for now, keep cool and continue working on more Electron applications. Thank you.
If you've made it this far, then you are ready for more on Electron. When you enroll in this full course, you will receive 6.5 more hours of HD videos, and we will build 4 more advanced applications, including a radio streaming application, a top headlines news reader, a system tray application, and a complex music player. Also, I'll teach you how to package all the apps that we've built for the different operating systems that we have, being it Windows, Linux, or Mac OS. I am very active in this course, so you can ask me any questions that you have in the Q&A sections, and I will be there to answer you, until answer all the questions that you have. So go ahead and use the coupon code YMAGIC, or click on the link in the description below, which has the coupon code already applied, and it should bring you to this page over here, and get this course for $9.99, which is going to be a 90% off. Thank you for taking the time to watch this, and I'll see you in this course.